let me show you guys distance time graph. It's not the same as displacement or position time graph. This is distance time graph. So let's look at all the scenarios. So when the object is rest, uniform motion, accelerated motion, decelerated motion. So I'll start with deceleration. That is, the object initially has some positive initial velocity, but it is slowing down. That is, the acceleration is negative. So let me show this. Okay, so you can see this is a scene of deceleration. Actually, let me make it a bit more. Yeah, now it would be better. You get to see the deceleration. Okay, so let's have a look. Right, can you see that? Decelerating. So this is a case of decelerating. So you'll get to see behavior, or let me continue to do that. After decelerating, the object is actually going back. Can you see that? It's kind of right. So let me show it with some different set of values so that it's kind of visible. Can you see that? So it kind of almost stopped. I think somewhere, yeah, that's the maximum. Oh, there is some more. There is some, was some more. And now it will be going back. Right? You can see that it's clearly going back. So you need to understand that the distance time graph will never fall. While you can see displacement time graph is falling over here, distance time graph does not fall. This is a case of your object decelerating and retarding and all of that. It's going back and all of that. But with all of these variations, the distance will never drop. My bad. The distance will never drop. Right? So at 15, we can see it's kind of flattening a bit. So you can see 15 here too, it's flattening. Then it'll start going in the negative. It's start to reduce while the distance, it keeps on increasing. The rate at which it keeps increasing, that's different, but it's always greater than or equal to 0 unit. So this can be anything. It can be 0, positive and negative. It can be anything. So that's your distance time graph, and this is displacement time graph. Then what else we have? This is decelerated motion. Accelerated motion, accelerated if it's positive acceleration, right? Something like this. So you get to see the displacement time graph and distance time graph, they look the same. While if it's moving in the opposite direction, let me show that. Again, guys, I'm showing a lot of variation. I'm not taking screenshot of everything. So you guys should be able to. Wait, I thought I gave a negative value. Just a second. Oh, my bad. This I wanted it to be negative. So now I'm making the turtle go back. So you'll get to see the following. So you can see that, again, please ignore this bump. Please ignore this. Yeah. So you get to see that displacement is falling. Okay. And please ignore the values for displacement. I need to change few things on the code to make it work. But yeah, while the distance, it is increasing. Displacement is reducing while the distance is increasing. That's the difference I wanted you guys to see. It's accelerated while the displacement is reducing, distance is increasing. This is possible. You guys should know all the possibilities. Okay. So when it comes to uniform motion and at rest, the behavior does not change. So, oh yeah, actually it does. I mean, uniform motion, but in opposite direction, negative direction is a possibility. So let me show that as well. So there is a variation here as well, actually. It's minute, but it's still there. So this is a uniform motion. Again, ignoring the bump over here. If I ignore that, so you can see that it's reducing while this is increasing. Actually, let me change that somewhere along here. I have to change, forgot. Let me take a second. Okay, so I have it now. So let's do it. So it's moving at uniform motion, right? But in the negative direction. I just wanted to show you guys this. So let's look at the graph. So displacement, if we start from the origin, so displacement turns out to be, going down. It's moving left, right? From the origin, it's moving left. While the distance, it doesn't matter. For the distance, it can be anything, any scenario. It's always this. It's always this. Okay. So that's that. There are quite a few variations, and I think I showed everything. When an object is rest, both distance and displacement will have flat slope. So we have distance and time, displacement and time. So we have to be careful with positive, negative, and zero and all of that. So that can be the difference. So distance is either a flat line like this or this. While the displacement can be a flat line on the origin or on the positive side or on the negative side as well. This is a possibility. Displacement, it's always increasing in this manner. Sorry, distance is always increasing in this manner. While displacement can be this or this for uniform motion. Then what else? Displacement can have a parabolic shape, yes. Distance can have a parabolic shape. Displacement can also have a parabolic shape. But again, it can be in the other direction as well. And everything need not start with the origin. I'm just going with the flow. Displacement, sorry, distance can go something like this, and even this is a possibility. For displacement, even this is a possibility. It can go up, flatten, and go down. Oh yeah, by the way, this can also flatten. That is a possibility. It can go flat. Means the object is at rest after certain travel, like over here. But it can't drop down. That's the difference. So those difference I have written over here. So following would not happen in distance time graph. Same time, two different places. So for that, I'll show this. So we can't have something like this. So if for a time 3 second, the object is over here and over here. So same object at two different places, not possible. Not possible. Actually, it's not possible with any of the graph. reduction if distance, if distance, okay, I think in distance, even if the object travels back to the origin. In, by the way, reduction in distance. So that I showed, right? So object can go back and forth like this. For this case, the object is going back actually to the origin. But our distance graph will keep increasing. That also I showed. Going back in time. So that is again not possible with any graph. This is a case of going back in time, right? So those are the different things that you have to keep in mind. There are a lot of small things, guys. You will have to do it yourself. You have to interact with this code and look at all the possibilities. Be aware of the possibilities. Distance time graph, displacement time graph can be very confusing, and I myself can ask a lot of tricky questions. Think about people who are trying to test you guys and make you get confused. So they will be eager to use all of these different scenarios to confuse you. Okay. So yeah, please have a go at it. I am not able to show all the variations again. So you have to do it yourself.